You know, every single time you hit send on an email or tap buy now on a website, you're basically launching your personal information into the wild west of the internet. So, how does it actually get there safely? Well, today we're going to pull back the curtain and see exactly how these modern digital fortresses are built. Let's jump right in. Just think about it for a minute. When you log into your favorite app or you buy something online, your data goes on this incredible journey. And it's a journey through a digital world that is just crawling with automated attacks, bad actors, and all sorts of constant threats. So the big question is, who or what is actually standing guard? This quote just nails a fundamental truth about staying safe online. You can't just bolt security on at the very end, like it's an afterthought. It has to be woven into the very fabric of the system, right from the first line of code. It's not something you add, it's something the entire system is. So when we talk about security, what are the problems we're actually trying to solve here? Well, it really boils down to these four big challenges. First, we have to know who we're talking to. Second, once we know who they are, we have to decide what they're allowed to do. Third, we've got to protect our front door from just getting hammered with attacks. And finally, we have to keep the lights on and make sure the whole service doesn't just fall over. Okay, to see how this all fits together, we're going to follow a single, simple request. Let's say it's your request, on its journey through a modern, secure system. You can think of it like we're following a secret agent carrying a sensitive message through a whole bunch of checkpoints.
And here's our mission map. Pretty much every request you make follows a path just like this one. It starts with you, of course. Then it has to get past the outer perimeter. That's the CDN. If it looks safe, it gets to the main gate, the API gateway. From there, it's got to pass two critical ID checks: authentication to prove who it is, and authorization to see what keys it holds. And only then, if it passes all of that, does it reach its final destination.
All right, so our request's very first checkpoint is this digital perimeter fence, the Content Delivery Network, or CDN. Its main job is to spot and stop the really obvious threats way before they get anywhere close to the important stuff inside. This is our system's first, and you could argue its most important line of defense. And the security guard at the gate? It's a real multitasker. It uses TLS to encrypt all the traffic so nobody can eavesdrop. It's got a web application firewall, a WAF, that inspects every single request for known suspicious patterns. It uses rate limiting to stop a flood of traffic from overwhelming the system, and it has bot detection to weed out all those malicious automated scripts. It's a really powerful combo. So here's a classic example of that WAF doing its job. An attacker tries to be clever and smuggle a malicious database command inside what looks like a totally normal request. This trick is called a SQL injection attack. But the WAF, it's been trained to recognize exactly these kinds of signatures. It spots that dangerous code and, boom, blocks the request instantly. And this, right here, is the power of edge security in a nutshell. That malicious request is stopped cold right at the perimeter. It never even got close to the real application or the database. The threat is just gone. And the main system has no idea an attack was even attempted. Pretty cool, right? Okay, so our request made it past the outer wall. It's not an obvious attack. Now the system has to answer a really fundamental question. Who exactly sent this? And that brings us to the absolutely crucial process of authentication. To put it simply, authentication is all about identity. It's the digital version of showing your driver's license at a security checkpoint. The system needs to be really, really sure that you are who you say you are. The way we do this now is with something called OAuth. So instead of giving your password to every single app you use, which is a terrible idea, by the way, you get sent for a moment to a trusted place, like Google's login page. You prove who you are once to them. Then they give your app a special temporary digital key. We call it an access token. And it's this token, not your password, that gets you in. So why is this method so much better? Well, first off, and this is the big one, you never actually share your password with the app itself. Plus, these tokens are temporary. They expire. So even if one gets stolen, its useful life is super short. This whole system works great across tons of different services, and because the token itself carries the information, it's incredibly efficient and can scale up to millions of users. Okay, so the system knows who you are. We're authenticated, but that's only half the battle. The next and just as important question is, what are you actually allowed to do? This is authorization, and it's all about permissions. Right, so if authentication is like showing your ID to get into the main building, Authorization is what's on that ID that determines which doors you can open once you're inside. Can you get into the server room, the CEO's office, or just the cafeteria? That's what authorization decides. There are two main ways systems handle this. On the left, you've got role-based access control, or RBAC. It's pretty straightforward. You get a role, like editor or viewer, and that role has a set list of permissions. On the right is the more powerful attribute-based access control, or ABAC. This one's more dynamic. It can make decisions based on all sorts of things like what team you're on, what time of day it is, or even where you're located. So we've got these amazing tools for figuring out who someone is and what they can do. But how do we put it all together to build systems that can handle millions of users and fend off constant attacks without breaking a sweat? This gets us to the challenge of creating security that can actually scale. You know, it's so important to understand that security architecture is always a game of trade-offs. OAuth is fantastic and scalable, but it can be tricky to cancel a single token before it expires. CDN security is a powerhouse, but it costs money and can be complex to set up just right. And while role-based access is simple, it can be too rigid. The flexibility of attribute-based control is great, but it's often way harder to manage. There's no one perfect answer, just the right balance for what you're trying to build. So, what are the big takeaways here? Well, these are really the best practices that guide how we build secure systems today. Always use tokens that expire quickly. Change the secret keys you use to sign them on a regular basis. Assume no network is safe. That's the zero trust idea. And finally, the golden rule. Only give a user or a service the absolute bare minimum permissions they need to do their job. We call this the principle of least privilege. And that brings us right back to where we started. From that CDN at the very edge of the network to the authorization rules deep inside the application, security isn't just one thing you add. It's a holistic property of the entire system. Every single layer has to work together, reinforcing the others, to create a defense that's truly strong. So, this leaves us with one final thought. Whether you're building something new from scratch or you're looking after a system that's been around for years, everything has a security posture. Looking at all the layers we've just talked about, the edge, authentication, authorization. What's the first area you'd focus on to make it even stronger? Thanks for watching.